If you're out and about near the water, it's more likely that you might be keeping an eye out for interesting bird life, dolphins, or even whales. But have you ever considered stopping to search for some of the tiniest insects in the water? Well, they could hold the key to learning about the prehistoric history of the Falklands.
It looks like a little ant. It's actually it's called a chironomid midge. We'd think about those as swarming midges if you're used to seeing midges swarming near a riverbank under trees. That family, but in evolutionary terms, this one has lost its wings. So it runs around on the ground and it swarms on the ground. So most people who see it think, oh, well, what's that ant doing there?
The Telmatogeton magellanicus is a small ant-like midge that lives on the algae in Stanley Harbour. Members of the same family species have been found in Antarctica, South Georgia and South America.
And we've got some molecular biology data that shows that the South Georgia Antarctic Peninsula ones separated 40 to 50 million years ago. That tells you they've been there for that length of time. And we're in the process of getting molecular data for the Southern South American ones. And we've now got material of one of the species from here, which helps us fit that into this pattern. It basically says how long have these organisms been here, how long have they been evolving separately. That can link in with the geology. So all of those regions, well, other than the Falkland Islands, all of those regions 30 to 40 million years ago were joined together. And it's only in the last 30 million years that they've moved to their current positions. And they've carried this little raft of insects with them.
But it's not just the one species of midge in the islands. On this trip, Pete discovered another with wings that could well be a new species. The chironomid midges in the islands have adapted to suit their specific habitat here. Their adult life cycle lasts only a few hours while the tide in Stanley Harbour is out, before they lay eggs in the algae and die. It's evolutionary tricks like these, as well as that molecular data, that can help researchers learn about the history of the islands and land masses they used to be connected to, and put those puzzle pieces together.
I mean, people always talk about the geological history of the Falklands and very ancient origin somewhere near South Africa. You don't see that in the biology. That's long, long gone. But being able to relate essentially a fairly isolated set of islands to what is probably the source populations in South America, have some idea about when or how frequently the colonisation events happen. We've always got to look at it as the bigger picture as we're looking at the other species in the other parts of the region. So basically it's fitting all the little jigsaw pieces of this part of the world into one story, which people haven't tried to do in that way very often. And they certainly haven't tried to do it with the insects.
So next time you're out for a walk, why not have a look and see if you can spot some of the island's smallest creatures.
The things people don't notice actually carry an awful lot of very useful biological information. We're obviously very attracted to the megafauna, the big things, the spectacular things. I am as much as anybody else. I photograph penguins while I'm here. But there are many things you can do with very small invertebrates, very small plants, that don't grab people's attention but do tell a very important story.